Okay, so today we are doing a review for the final for Precalc Semester 1. Here's a list of all the topics on that front page, and if you just wanted to, you could go through that way and say, ooh, I don't think I'm very good at point slope form or whatever it is, and like narrow it down that way. But there are 23 pages of problems here, or actually I guess the first page counts as a page. There's 22 pages of problems, and the very first one here, this one stumped a lot of people. Problem number 1. If you already have it, you probably would know this. But if you were going to do this one, you do not do 14x and x. That's a way you could have gone, but you cannot make it factor that way. No matter how you arrange the 5 and the 1, which are these other two numbers that go here and here, if you have a 5 and a 1, you're not going to be able to make a 33 in the middle. If your only hope would have been to put a 5 here and a 1 here and to make this negative, but that ends up being negative 90 or something like that, and it's way too big. If you put the negative 5 here, it still doesn't work. So bottom line is, you can't use a 14x and an x. So what else could you possibly use? 7x and 2x. And then you need to figure out where to put the 5. Well, if you need a 33, it makes some sense that you put the 5 here so that it goes with this, and that makes 35, and that's really close to 33. And so then you can figure out that, oh, well, I can put the 1 here, and then you got to figure out where to put the negative, and I'll let you finish the problem. At least there's a start on number 1 on the first page. Now, I know the first page is basically just factoring. It's not too tough. So, but I would be glad to entertain any others that you need help on this page. Are there any other ones you'd like to see done? Otherwise, we'll move on, and I'm sure we'll get to ones that you need help on. Yes, ma'am. Yes, you do not have to give the answers. Factored completely just means make sure you aren't like forgetting something. Like let's say that the problem factored and it factored down to this: x squared plus 2 and x squared minus 4. Factor completely just as a reminder that you need to factor it all the way. Like that one right there should be factored to what? Yep. So it's just about factoring it all the way. Do not have to actually get the roots, the zeros, the solutions. That's for a different section. Okay. Any other things you want to know about on this? All right, here's a common mistake one, B. Everybody look at 2B as in banana. If you took the square root right off the bat, you made a mistake. It might work for you, but especially when this number doesn't have a nice square root. The title I would use on this one is Get the Clump Alone. Do you remember the Get the Clump Alone thing? It's a funny saying, and basically it's trying to remind you that this clump, this x squared right here, needs to be alone first. So you divide by 4 on both sides. Then you square root, square root, square root. And the square root of x squared is not x. It's the absolute value of x. And the square root of 25 is 5, and the square root of 4 is 2. That you can do. And then that'll remind you that absolute value that you need to have plus and minus 5 halves. Is there another way? Sure. You could use quadratic formula. What if you could factor it? Sure. If you can factor it, that works. So factoring solves quadratics. What if you can't factor it? You're supposed to have an automatic answer for that one. What if you can't factor it? Quadratic formula. What if you can't quadratic formula? Then there's probably no real solutions. So, and that would probably mean you're not going to be getting any answer out of it, or out of it. All right, so let's move on then. If there weren't any more questions on that page, look at the page that has a G, H, I, J, etc. Are there any on this page that would scare you? Think of it from that perspective. If you're taking the final and you come across these questions, because we're really good about not trying to fool you on what's on the final. This packet is very inclusive. If you see it in here, you can probably expect with about an 80% certainty that there'll be one just like it on the final. How big is the final? Good question. I believe it's around 32 questions, and it's all our 3s, I believe. So like, for example, on your most recent cumulative test, that covered 4 tests, and we had 4 problems of each kind. So that would be a total of 16 R3s that you had during one class hour. That was our most recent cumulative test. And granted, it took a while. It took pretty much the whole hour. But it's going to be like that, except double. So it's like your cumulative test times 2. Yes? It is not multiple choice. It is free response. Believe me, I wish it was multiple choice. You can imagine for me the perspective of if you each have 32 questions and I have 90 of you, that's 2,700 problems I get to grade by hand. Ugh. I'd much rather have multiple choice. But the logic was that you guys, it wouldn't be fair to give you a multiple choice test because you had never had any multiple choice problems all year. You would have been okay with that, huh? Yeah. Anyway, so it's something where I feel like, to me, granted, the easiest thing is multiple choice for the whole thing. My ideal world was have been there. This would have been like half multiple choice and half free response, about the same number of questions. And there are some, I have to admit, that are a real pain to do multiple choice on, like graphing. I say graph this and then give you all the answers in graph form. It's not nearly as good as actually having you by hand graph it. So this some, I think the best of both worlds is usually a compromise, but that kind of is how my personality is. If there are two people that disagree, I usually figure there's something in the middle they can compromise. So anyway, but this one is all free response. But it's not ungodly hard because the problems are all problems you pretty much have done before. It's just like finding your R3s that you've had before and making something similar to it, and that's what we put on the test. We're not making up brand new concepts here. Oh, by the way, the last thing is, since it's all free response and all Marzano, we are going to grade it Marzano style, meaning that if you get a 75%, you get an A. So that's a really good thing. That's not a bad thing. That's a good thing, because 75% getting an A is a really good thing. Yes, sir. It's a good question. I do not have that answer for you yet. Whether or not a 50 or 2 out of the 3 or 50%, which is kind of comparable to the 4-part deals on the cumulative, whether or not 50% would be graded like a cumulative where we give 80%, or if I don't know. I can tell you the 75% is an A thing for sure, and I think most of you, that's probably what you should be going for. But I will get that answer for you, but I'll have it tomorrow. Yes, ma'am. No, Precalc has never allowed note cards. One of the reasons is that Precalc really is not dependent on lots of formulas to memorize. There's really not many formulas. So that's where note cards really are handy anyways, formulas. So you know that the main reason they make you make note cards is it makes you study, right? And it's true. When they allow note cards, it's just a smart way to get you to think about making this note card, and therefore it gets you studying for final. So, but no, we don't allow note cards in this class. I wouldn't actually be opposed to it, but we've never actually done it. Yes. This is, I assume you're talking brainstorming here, but we're not going to do that now. But what would your idea be? A copy of what? Oh, you mean the top 20? Gotcha. Top 20s. Okay. Those things are base little skills that do trip people up in all these problems. But you know, there's none of these questions are that easy. You know what I mean? Like, this would be something that's kind of on the top 20. This letter, what is that? L, I guess it is. Just in that you've got to rearrange terms and know your algebra. Anyway, let's get back to what else do you want to see solved in here? I can do any of these. Those are good questions. It's good for you to know about what the final's going to be like. Yes? Yep. When you're solving them, you would want the number line. Just to clarify, whenever there's this kind of a symbol, yes, you would want to use a number line to get your answer. Whenever there's an equal sign, then you just want the answers, and there's usually 2 of them, and a lot of times one of them's imaginary, or excuse me, one of them is extraneous, like it doesn't actually work in the problem. Especially when they have fractions. I guess none of these have that, but anyway, bottom line is, yeah, you do want a number line in pretty much anywhere where there's a less than or greater than symbol. Think of that as the end of a number line, and yes, you'd want one of those. So then it'll be an interval notation when it's all done. So you'd have, like, find a couple roots that are important, say it's 0 and 3 or whatever, and then Then you'd say it's from 3 to infinity if it's like that. So yes, number lines would be good on all these problems. Again, I'm willing to do any of these. Are there any specific ones you want to see done, or should we just move on? Letter, which letter? I think it was up. E, yes. I'd be glad to help you with that. First off, do you get that this has an absolute value and therefore can be broken into two parts? It's true. So there, if this had just been an x, you'd break it into two parts and say x is greater than or equal to 3 and x is greater than or equal to negative 3. But when I change this sign, do you remember that that makes this sign switch to the opposite? If you ever multiply or divide by a negative, it changes the sign to the opposite. All right, so I now have a more complicated question, though. It's x plus 2 over 3, but it's the same concept. X plus 2 over 3 and x plus 2 over 3. Notice that this is identical to this except for that negative sign right there. And in this kind of inequality question, the inequality has to switch to the other way. Now I'm going to multiply both sides by 3 times 3 times 3 to clear the fraction. I can multiply by a number on both sides. I just can't multiply by a variable on both sides. So that'll give me x plus 2 greater than or equal to 9. Subtract 2, x greater than or equal to 7. And the other part of your answer is over here. Multiply by 3 on both sides. X plus 2 less than or equal to negative 9. Subtract 2 from both sides. X less than or equal to negative 11. And then you could put those both on a number line if you want to kind of see it pictorially. And then the final answer would be from negative infinity to negative 11, union with from 7 to infinity. Okay, any other ones that you want to see? This page or the next page? A bunch of letters. C, F, G, H, I, J, blah, blah, blah. Anything in here? Okay, then I'm moving on. Everybody get to Q, R, S, T, etc. This is the unit we just finished up. You just have to, if you can factor it, you should. And then you want to clear your fractions on a problem like this by multiplying through. On a problem like this, you want to get the clump alone. That clump is alone. And then you take the square root on both sides. Or sorry, square both sides. On a problem like this, you'd want to set up a number line. Notice it's got an inequality. And then you want to factor the top and factor the bottom and then find the spots that are important and test the regions around it. I know this is all very recent, so those I think are probably why I'm not getting any questions. Okay, then. You can stop me at any point. I can even go back a page if you want. Yes? 3B. Yes? Yes. All right. I'm going to do how to do these domains in clumps. F plus, F minus, and F times. Everybody please be on this page on your iPad. 3, both A and B. Would you please turn your iPad my way so that I can see you're not playing Clash of Clans and you're actually with me? Still waiting, Mr. Sweatshirt. Waiting for 2 people. I will have you show it to me in a moment. Rapido, por favor. All right. Where you add, subtract, or multiply, those 3, you just have to have the 2 parent F and G domains, and you see where they overlap. So if I was going to do F plus G, I just take that plus that. That's it. Then, how do I get the domain of it? Domain of F and domain of G, and I just see where they overlap. The domain of F is this guy. I'm going to set x plus 4 greater than or equal to 0. Then I subtract 4. X is greater than or equal to negative 4. So here's a negative 4. And now, domain of G. Here's G. Its domain, there's nothing that would crash it. All reals. And then you ask yourself, just for these 3 kinds, you just have to take the 2 F and G domains and see where they overlap. Where do they overlap? From negative 4 to infinity. All right, so that's add, subtract, and multiply. How about F over G? Do you remember that that has 3 number lines to check? Domain of F, domain of G, and for the Megabucks Million Prize today, domain of, not the new. Nope. When g does not equal 0. So again, here's my two functions I was asked to consider, this one and this one. And the g function is on the bottom of this fraction, right? So the g function, which is x minus 2, this guy, normally it's okay to be 0, but not if you're on the bottom of a fraction. So now we have to figure out what would make this equal 0, and it can't be that. Okay? If I put in a 2, it would make this equal 0. So it can't be 2, but it could be anything else. This number line is only saying what would make the denominator be 0. We still got to do the domain of g, which is this whole thing's domain, which is all reals. And then we'd have to do the domain of f, which was from -4 to infinity. We already have that right here. So let's copy that back in there. And then you'd ask yourself, where, I'm going to move this -4 over a little bit further. More like over there. And the question now is, where do they all overlap? They all overlap from there up to 2, and they all overlap from 2 to infinity. So that kind has 3 number lines. And the last kind is the kind that are nested in each other. That's called a composite function. And those have 2 number lines. Domain of the inside, which in this case would be g, and domain of the new, or the composite function. If I put dc, is that going to confuse you too much? I was using domain of new mostly, but the new function is a composite function. So the new function you've made by putting the one in the other, the g would go into the f, so it would be square root of empty spot plus 4, and then I drop in x minus 2. And then I'd figure this out as x plus 2, and I get square root of x plus 2. You find the domain of that, the new function, this is the composite function. And that's the other one you overlap it with. So this right here is the domain of the composite. Okay, so to do it for this question, domain of the inside is the domain of g, and that was all reals. And the domain of the composite function, here's the composite function, its domain is x plus 2 has to be greater than or equal to 0. X is greater than or equal to -2. And here's a -2, greater than or equal to that. Where do they overlap? From -2. Okay, so that's the 3 kinds of domain situations. The simple kind like this, where you just take the 2 f and g's. And this one, where you take f and g, and g cannot be 0. And this kind, where you do the domain of the composite and the domain of the inside one. That sums up one of your most complicated things. All right. Let's move on. Past this page to maybe something on this page is something you'd like to review. 4, 5, 6, 7, etc. Do you remember inverses? Because that's definitely on there. Doesn't take too long to explain if you need me to. Do one of those? Which one? Pick one. So is that 6, 7, 7D? Okay. I think I got to ask D first. I'll do D first. That one right there. And find the inverse and its domain and range. I'm going to do its domain and range first, because so often people think that they wait and get the inverse and then find the domain and range of that. You actually are supposed to find the domain and range of this, and then you flip it. You remember how an inverse reverses the x and the y? That's what inverses do. So that means your domain becomes the range, and your range becomes the domain. So then what's the domain in this thing? Domain is all reals work except what? That's the way I like to think of this. -4. X cannot be -4. And the range of it. Range is, on a picture, it's from low to high, right? And these fraction functions will cover everything except what stops you when you're moving from low to high. An asymptote line would stop you. So how about those horizontal asymptotes? The horizontal asymptotes are, I like to call them the horizontal asymptotes because that reminds me that they are which letter? The y equals. So all reals work except y cannot be whatever the asymptote is. Okay, what is the asymptote here? Is this a bigger on bottom, bigger on top, or same on both? It's bigger on the bottom. What's the rule for Bob's again? 0 plus if there was anything on the outside, because then it would obviously move the asymptote up like 5 or whatever. This has nothing on the outside, so it's y equals 0. Why cannot be 0? Because y equals 0 is an asymptote. So therefore it can't be that. All right, that's a reminder on how to find the domain and range of a fraction function like this, a rational function. Just wait. And so then, okay, that's the domain and range of this. What they wanted is a domain and range of the inverse. So, to go down here where I'd normally write the answer for my inverse, you know, after I did the problem out, the domain and range get reversed. So, the domain becomes the range. So I'd say all reals except, now ranges don't have x's in them. If I just simply blindly copied it, I'd say x cannot be -4. So I had to change it to y cannot be -4. And the domain of it, the range, I don't blindly copy it. I say all reals except domains are supposed to have x's in it. X cannot be 0. Could I have written that in interval notation? Yes, that would have been great. Yep. Well, remember, go to the directions. If the directions don't say, you got your choice. Okay, so then that's actually do an inverse. How do you find an inverse? It's a 3-step process. First you change this to a y. Then you reverse the x and the y. Remember how they get reversed? So this becomes x equals 6 over y plus 4. And then you solve. How do you solve for y then? You multiply both sides. Remember, those general rules, like you want to clear your fractions. So I'm going to multiply by y plus 4 on top and, or sorry, left and right. And this cancels that. So now I'm going to multiply it out. xy plus 4x equals 6. And now, is my y alone yet? No. That's what you keep asking yourself. What am I trying to solve for? I'm trying to solve for y. So I subtract 4x. xy equals 6 minus 4x. Is my y alone yet? No. So what I have to do to get it alone, divide by x. Y equals that. There's my inverse function. 3-step process. All right, 2 people that weren't on the right spot before, would you show me that you're there with me now? Excellent. Okay, thank you. Yes. I know what you're talking about, yes. If you had done, see, this one only has a single number on top. This one has a variable on top and bottom. I'll just do a real rapid fire version of that one then. So everybody go to E as an elephant. I don't do the domain and range on this one just to save time. I'm going to go right, so this is a y, so then I change it to x equals y plus 3 over y minus 2. And notice there's 2 y's, and that's when this is going to happen. So now I'm going to multiply by y minus 2 on both sides to clear that, for the denominator. And now I have xy minus 2x equals y plus 3. Now, I've got y's here and here. First, I got to get them to the same side. Then I got to factor it out, like you said. Minus y, and I'm going to do a double step here. Plus 2x and plus 2x. It's just going to save me space. xy plus 2x. No, wait, plus 2x and the minus 2x cancel. Minus y equals, those cancel, 3 plus 2x. Okay, then here's the factoring part. Y comes out, x minus 1 equals 3 plus 2x. Final answer, I put it in green because it's going to go over black. Dividing by x minus 1, and that's gone, and I got y alone, and it's 3 plus 2x over x minus 1. That's an example of one of those kinds. All right. Any others you'd like to see off of this review packet? Yes, ma'am. There we go. Okay. Yep. Let me think. Since I'm trying to make this review kind of complementary to the one I did in a different hour, I'm trying to think of which one I did in the other hour. I did A in the other hour, so I'm going to do B for your hour. So if I was going to do this one, and I have to find F and G, this is called decomposition. This is a composite function. That means it's made up of two functions, one inside the other. What they're asking is, if this is h of x, which is the combo of both f and g, they want to know what's f of x, what was f of x, and what was g of x. Do you remember this one where you just pick anything to be g of x that's on the inside? Kind of like, I can pick that part right there to be g of x if I want to. I pick any individual like little chunk, and I say if g of x was 3 times x squared minus 9 quantity squared, okay, then the other function would have had to have been everything without that, except I would, wait, then I'd have, that wouldn't be so nice. This one wouldn't be so nice. I shouldn't use that. I bet somebody else has seen it now. What should I choose as the g that got put into the other function? X squared minus 9, very good. That part right there, because it appears twice, I should use that. So I'm going to make g of x be x squared minus 9. And what that means is the f of x would have to have an x where both of those circles are. So it's 1 over x plus 3x squared. So now, the way you can tell you're right if you did a decomp right, again, you just pick anything to be the inside that you want. And in this case, since there's 2 of this, it made it pretty obvious that was the logical choice. And then you can check yourself by just sticking it back in. If I stick that in there and that in there, I'll get the original answer that I wanted. So I'm double checking it by like multiplying it back out. Making the composite of those three. All right. Yes, you get better after a while than just guessing, but if you want to guess and check, you can. Take any portion of it that you want that involves the variables. Okay? I can't just like pick this 3. That doesn't work. I have to involve the variables. And then I grab that to be my g of x. Then I figure out what f of x would have to be with an x there. And then you can check it. All right. I thought that was a good one to ask, and it's been asked in both my hours. That obviously shows you weren't the only one wondering about that. Okay, let's move on in general. We're on page 7 here. My goal is to get through 10 pages of it today, so we're getting close-ish. Page 7. You get these how much acid to add. We just did those pretty recently. Okay, you got that formula. Amount 1% 1 plus amount 32% 2 equals the total amount and the total percent. Yes? Good question. The cumulatives that you're going to get back today, oh, wait a minute. Did you get them back before today? Oh, that's right. I was gone, so I haven't given them back to you. Sorry about that. I will give those back to you today, and they are not in Skyward yet, but they will be in Skyward probably by tonight, I would say. And remember, the cumulative doesn't affect, your grade that much unless you signed a bunch of things asking for them to be counted as retakes. Remember that if you signed stuff and you had not actually done the corrections to qualify you, they won't make your grade move up. But anyway, yeah, I'll get you those cumulative scores later today. Thanks for reminding me. Yep, I can remind you how to do this. F of x and g of x, and again in my other hour I did that one, so I think in this hour I'm going to do this one. F of g of x needs to be equal to g of f of x, and they both, when they're all done and simplified down, remember how they always come out to x? That's how these work. You find f of g of x and g of f of x, and you've got to make sure they both equal x again. Okay. The key is to do this in the right order because we all know how it ends. We all know it comes out to x at the end. So the question is really, can you put the one function in the other and then do the canceling in the correct order? So if that guy goes in there, I'll have empty spot cubed plus 1, and I drop in cube root of x minus 1 from right there. Okay? Now I need to simplify it. Now in the order of operations, agree that powers are early on in the order of operations? Technically, you could argue that this is like a parenthesis, but I can't do x minus 1. There's nothing to do there, so I can move to my powers. Please excuse my dear Aunt Sally. Parentheses are first. Exponents are next. I'm going to do the exponent. So then I have x minus 1 plus 1. Could I have done it in the other order? No. The order of operations is what this is all about. Then this is the last thing to cancel, obviously, so I'm left with just x. Okay, on the other side, g of f of x, I'm going to put the f into the g function. So the g function looks like this when I put an empty spot where the x was. And then I'm going to drop in x cubed plus 1. Okay, now what's first in the order of operations? Parentheses. This is like a big parenthesis. Is there anything in there I can do? Yes, there is. So the plus 1 and the minus 1 cancel off. Cube root of x cubed is left. I know that seems weird. It's like, wait a minute, on the last problem you didn't do that. Well, I did look to see if there was anything underneath the root, because parentheses come first. And please excuse my dear Aunt Sally. Parentheses are first. This is like a parenthesis. It's a grouping symbol. So what's in here should be done first. Okay, so then that can cancel that, and now it's down to just x. Okay, so that's a reminder of proving inverses. Any questions on clarifying questions on that before I delete that writing? Okay. Then let's move on to regressions. Remember how to do those? We've done linear. We've done what else? Cubic. What else? Quadratic. Yep. And there's one last kind. Power regressions. So you'd go into stat on your calculator. You enter your data, and then you go to calculate under stat. You're still under the stat button. You go to calculate, lin reg, or quad reg, cube reg, or power reg. Remember those? Okay. Most people seem like they're good at that. If you want to ask me personally, you can always ask me later. All right. Find the y-intercept. Repeat after me, or not repeat, but say what you're supposed to say here. The y-intercept is where what? X equals 0. Very good. So all you have to do is stick in a 0. Here, and here, and here, you stick 0 in, and you figure out what the y-intercept is. And the x-intercept is where y equals 0. So that little statement can come in, and its corollary can answer a couple questions. All right, moving on. We're on page 9, so we're getting close. The graph here, this is one of those Franken functions. Its head came from one body, and its arms came from a different body. Well, anyway, this guy goes up to 0, which is basically in this zone from here to here. That's going to be one function. Then between 0 and 1, it's a different function. So like right in between those two lines, in this little zone, I'm just going to graph that function. And then from bigger than 1, which is basically from here to here, it's a different function. So it's 3 different functions. So my first thing I would always do if I were you is to put in some dotted lines to kind of divide up your function and say, in this first part from here to here, I'm going to graph this one right here. Then I would write it in normal form, minus x minus 3. Why is that any better? Because that's the slope, and that's the y-intercept. Y-intercept of negative 3 touches right there, and has a slope of negative 1, so it's going like this. And I know I'm doing it from right to left, so it seemed like it was rising, but it actually is falling all the way to there. Okay? Now, remember that the endpoints are super important. Does it own that spot right there? Yes, it does, because it says or equal to 0. It owns the 0. Does this next guy own the 0? No, he can't. That next guy is just y equals 1. Y equals 1. But it only happens between 0 and 1. Y equals 1 is this little line right here. But if I did it just like that, I'd have to mark it wrong. Because the endpoints are so critical, I need an empty spot right here to show it doesn't touch there. And notice it's also not owning the 1. It doesn't say or equal to 1. Empty spot right there too. And then to finish it off, this last part's a parabola. And these can be weird because normally we graph parabolas by the origin. So your XY chart is your best friend in graphing. So if you need to know what it is at this spot right here, which is x equals 2, you stick in a 2, you put it in the function. 2 squared is 4. So over 2 and up 1, 2, 3, 4. How about at 1? It doesn't own, or no, it does own 1, so I especially need to know it. So I'm going to put in a 1 there, and that's 1 squared is 1. 1, 1 is right there. You put a dot inside the other empty circle. And there's, basically, it's a really steep, it's hard to see because we're getting into the numbers that grow really fast there, but that's the beginning, the right side of a parabola. All right, there's an example of one of those Franken functions. Yes? No, don't just fill in the dot. You'd have to, if you have to a spot where they overlap, you have to have one be bigger and one be smaller and go like that. You need it to be clear. If it's just one dot there, you haven't made it clear which one owns it. So, all right. Clear off my ink again. Do you remember that this one is a volcano when they're squared on the bottom? And this one some people call the butterfly? Because basically, if you consider that like part of its wing, it's got that kind of a motif going. Anyway, I don't know if that really looks like a butterfly, but that's what some people call it. So I'm going to go with there and there. And then I just have to move it. 3 to the, and what's that? Up 4, good. And this one over here, it's a volcano, which basically goes through here and here. And then is moved 2 to the left and then down 3. Okay. Remember, even the XY chart can come in handy on this. If you're not sure you're doing it right, you just want to be careful. And you think, okay, I moved it 2 to the left and then down 3. Say I think that I've got it here. And I graph it like this and I go, okay, did I get it? Double check yourself. Maybe I should check that point, -2, -2, because I got a dot right there. Does -2 really work and give me -2? Hint, it won't. That -2 plus 2 is 0. 0 on the bottom. What? See, it didn't work. I screwed up. This was moved over too far. It should be here. -1 would work nicely. That's how you can check yourself to make sure you don't wreck your grade. Okay. Any other questions in this zone? I'm on page 10, which is kind of where I stopped in the other class. I was thinking up to here, up to number 16. Any last thoughts? Okay, you can always ask me more questions later. Again, final is coming, and it's going to be 15% of your total grade is your final. 15. I would say from my fairly extensive experience, usually people do a little worse on the final than they normally do on a normal test. If you are an A student, usually people get like an A- on the final. Or if you're a B student, usually people get like a B- on the final. Okay? But with the Marzano grading, it usually means it's not a real train wreck for anybody. The most your grade, don't count on the final to bring your grade up. I mean, everybody dreams, not everybody, but some people dream of that. They got the A- going, and I hope I ace the final. It's unlikely. It's really hard to ace the final. I mean, it'd be really, really hard. Could you get an A on the final? Sure, if you're an A student, yeah. But don't expect, if you've been a B student all along, that you're going to all of a sudden get an A on the final. That's like impossible. So it's really, really, really unusual. Now, if you, I'm just telling you reality, just don't want to get your hopes up for something that's just not likely to happen. I'll also tell you, you're probably not going to be a professional basketball player, and you're probably not going to win the lottery either. I know, some of your lives are over now. Now, can you get about the same grade you usually get? Yeah, if you study harder than normal, you'll probably be at least get what you normally get on tests. That's what's normal. That's what you can kind of expect. If you study a little harder than most people, you can get the same grade you usually get. And if you're an A student, you can probably pull off that A. Some of you have a high enough A that you could actually figure out the math on it, where you could probably get a C on this test and you could still get an A overall. Now, that's the benefit for those that have been just nailing all your tests all the way along. That might pay off here. Okay, and that's all I've got for you for today. We'll do more review like this tomorrow and again on Monday, and hopefully by then we'll cover everything.